So we're continuing to talk about special segments and triangles. We've talked about perpendicular bisectors, we've talked about angle bisectors, we've talked about midsegments, and now we're going to talk about medians. And a median, we draw the midpoints again, but instead of connecting midpoint to midpoint, we connect midpoint to vertex. And so the median is the segment connecting the midpoint to the vertex. So again, midpoint to vertex, midpoint to vertex, and midpoint to vertex. This one doesn't make a circle. The other two made circles, but this one doesn't. But it does all intersect in the same spot. This is called the centroid. And the centroid, the distance from the centroid to the vertex is always 2/3 of the whole median. 2/3. So this is 2/3 and this is 1/3. Now, I don't necessarily like 2/3 of the whole thing as much, and I'll explain that here in a second. So we have AP right here is 2/3 of the whole thing AE. And BP is 2/3 of the whole thing BF. Notice it's the distance to the vertex that is always the longer side. P to A, P to B, P to C. CP is 2/3 of the whole thing. It's important to realize which side is always the longer. Pretty easy to tell when it's drawn to scale. So 2/3 and 1/3. Now what I like to do is rather than think 2/3 and 1/3, I like to think related to each other, the pieces. This is 1/2 of this. Because if this is 2/3, this is just one of those. Two of these, one of these, so 2 times this. The longer part is 2 times the shorter part. And I would so much prefer that to the whole thing. So here's what I mean. We have BG is 8. So centroid to the vertex is 8. And so this side is going to be half as much, 4. AD is 12. And so remember these are medians. And so we're talking midpoint, so this is 12 as well. CD, this whole thing is 15. So this whole thing, if you split it up into thirds, so 15 divided by 3 is 5, and so the 1/3 part is 5, and the 2/3 part is 2 times that, which is 10, and so notice 5, 10 make 15. So what do we have here? Well, BD was 12, because it was the midpoint. CG we already marked as 10, which was really 2/3 of 15. But I really like to do 15 divided by 3 first, which is the short part, and find DG, which is 5. 15 divided by 3, and then multiply that by 2. BF is the whole thing, so that was 12. 8 plus another 4. And again, we found the 4 because the 8 is double the short side. This is the 2/3 part, and this is the 1/3 part. So we take half of the 8 to find the 4. And then you can do it with algebraic expressions as well. And so I'm going to start with the 24 and the 3y minus 3. The 24 is from the centroid to the vertex, and so this is twice as long as this is. So I wrote an equation as 3y minus 3, and I double it. So I get 6y minus 6. Distribute that. Add your 6, you get 30. Divide by 6, you get 5. So now let's look at another one. I use CG, which is this one right here. So this one right here, this distance is twice this distance. So if I double my 15, I can get double the 15, I get 6x. So 2 times 15 or 30 is 6x, and so then divide by 5 you get divide by 6, and you get 5. And so last but not least, we have the 11 and the 6z plus 4. Remember, the 11 is the short distance, so if we double it, it can equal the whole thing. So sometimes you'll have to use the 2/3, but if you can get away with it by doing just double the 11, you get 22, and then go from there. Subtract the 4, you get 18, divide by 6, you get 3. And that is the centroid, all based on G, the centroid, is 2/3 of this whole thing. Or in other words, this is 1/3, and this is twice the 1/3 part. So I always like to find the short part so you can divide by 3 and multiply by 2 to get this one, in case you ever get the whole piece given to you. Always find the short side because it's easier to divide by 3 than it is to multiply by 2/3. But that's just my own opinion.